Now, potential due to a dipole. So this is a dipole, midpoint, both sides LL, center point O. Now, for the dipole AB, if we select a point somewhere over here, we can select it anywhere. So this is any point P, anywhere. Where is that point located? Its coordinates are given as r comma theta. You have done it, polar coordinates. R comma theta means it is making an angle theta and at a distance r, this point P. But this is a vague language. Making an angle theta with what? With this thing? Dipole? No. With the dipole moment P. Say this, generally we write plus q and minus q, but I have written minus q and plus q so that the dipole moment is along this direction. This dipole moment vector P and this distance, that is called radius vector r. So dipole moment and distance r, they are inclined at an angle theta. So do we understand this thing? P is at a point r comma theta. Now, potential due to this minus charge or potential due to this plus charge would be given by V equals to K Q by R. Q for plus charge may be positive, for minus charge may be negative. But what is this R? R is the distance of the charge from that point or of the point from this charge. So suppose if the distance is for the plus charge, it would be R1, this distance. Similarly, if the distance is for the minus charge, it would be R2 from this point to this charge, R2. R1, R2 are not known. Only R is given. And what is given? Theta. So in terms of this, we have to find potential over here. Similarly, just like the previous sum, we will apply principle of superposition. That means potential due to this plus potential due to this. That would be the answer. Let's do that. So now, this is the final picture. Let us calculate potential. Just before that, let me tell you one idea only. Suppose this is a triangle. Now, if I draw a perpendicular on this line, if I draw this perpendicular, then this part and this part are nearly equal. We can say that in most of the cases, we will be finding this application in optics also. See, these two parts are nearly equal. So we will be applying this idea in this theory. How? See, R1 is not equal to R2. So we will do what? To find R1, R is given. Sorry, R1 is not equal to R. R1, we will make application of this thing. So R1 is not equal to R. Neither is R2. But we have to find R1 and R2. So we will be doing what? We will draw a perpendicular on this, so that this becomes a perpendicular. Then this side nearly equals to this side. That means this side from here and this side from here are equal. So if we can calculate this part from here, then that would be equal to R1. Okay? So let us go with it. Now very easy. Say this triangle. Can we say that this is also perpendicular? This is also perpendicular. So this is theta. This hypotenuse is L. So this part will be how much? And this part will be how much? We are interested in this part only. So this part, I'm writing it here, is L cos theta. Because this is the base of this triangle. So, can we write that R here, R1 here is equal to R minus L cos theta. Total R minus this part equals to this part and this part equals to this part, R1. In similar manner, we can produce this R backwards and we have to draw a perpendicular on this from this point. So, a perpendicular on this gives us a bigger triangle. Think of this triangle, this total triangle, this triangle. In this triangle, this is theta, so this is also theta. And if that is theta, then how much would be this side? This side also will be equal to this part, will also be equal to L cos theta. So this much is R and this part is L cos theta. So the total length of this would be R plus L cos theta. Now this total part will be equal to or nearly equal to R2. So R2 and this side and this side would be equal. So R2 would be given by R plus L cos theta. These are the two ideas. मुझको तो अभी टाइम टा बाँच गया बस वही बात कैलकुलेशन चलो
स्टार्ट
चलছে अच्छा ठीक है so start so let's find v
अच्छा एक तो छोटी खुले
so let's find v then so v total at this point P would be given by V due to this minus charge plus V due to this plus charge. Ready? So V equals to V due to minus charge plus V due to plus charge. So V due to say minus charge K Q sine divided by R2 K Q, this is plus Q divided by R1, so equals to K Q common. So K Q common, this is 1 by R1 and K Q common, this is minus 1 by R2. Let us put the values. R1 means R2 means equals to A minus B into A plus B, A square minus B square. R plus L cos theta minus R minus L cos theta. So RR will cancel out, so 2L cos theta. You can well understand, remember P, dipole moment, so that is total potential at the point P. This is the formula. So we saw that potential due to a dipole was K, that is 1 by 4 pi epsilon naught, into P dipole moment cos theta divided by R square minus L square cos square theta. This was the result. Now think of this. What if the dipole is very short, suppose this much, and the distance R is very large, suppose over here. So then what will happen, that R is very, very greater than L. L means half of the length of the dipole. So in that case, L square is further less, cos square theta is always less than 1 or equal to 1. So cos square theta either would be 1 or would be much, much less. So L square cos square theta tends to 0 if L is very, very small, and practically for molecular dipoles they are really small. So this part is gone. So whatever remains is that special case of V is 1 by 4 pi epsilon naught into P cos theta divided by r square. So potential is dependent on theta and distance. Now let us come to special cases of this over here. Case 1. Here theta is 0 degree. Look at the picture. Dipole moment is along this vector p, minus charge to plus charge, and the distance r is along this. That means p point is on the axis. So these two are having same direction. Theta is 0. Then this formula will become v equals to 1 by 4 pi epsilon naught. Think what will happen. P, okay, cos theta will become 1. This will become 1 cos 0 degree. So P divided by r square. So this would be V. But in this case, this condition holds good again. Similarly, for second case, here theta is 180 degree. That means what? Dipole is placed along this direction, but the point lies over here on the back side. That means vector P and vector R, distance from the middle point O, are in opposite direction. So theta would be 180 degree, cos 180 degree would be minus 1. So here we can write V equals to 1 by 4 pi epsilon naught P by R cube, but that would be negative because cos theta is minus 1. And what would be the case for this one? Here from middle point, vector R, it is this direction, and dipole moment, vector P, is in this direction. So the angle is 90 degree. If angle is 90 degree, cos theta becomes 0. So if cos theta is 0, total thing becomes 0. So here, V equals to 0. So remember this idea, potential is 0 at all the points on the perpendicular bisector of a dipole, anywhere.